Good morning, dear students. Welcome to this session on pre-stressed concrete. Last session, we have talked about the compressive strength, its properties of hardened concrete. We are taking up for discussion. So, compressive strength, uh, which is discussed in the last session, and the minimum grade of concrete required for pre-stressed concrete member, tensile strength, what types of tensile strengths are available, and the relation that you need to use in the absence of the test data, that this is the relation that you can use for flexural tensile strength of concrete. Okay, so the same relation you shall have been studied in your design of reinforced concrete structures also. The same relation holds good for even pre-stressed concrete also, right? So 0.7 times root FCK. Right. Next comes the stiffness of concrete. So what does this stiffness of concrete means? A deformation characteristic. It is nothing but the stiffness of the concrete. Like when the load is applied, how concrete deforms, deflection. Okay. So this is what we say the property stiffness. Okay, so why the estimation of stiffness is required is to find the deflection of member. Okay, and the stiffness is measured in terms of modulus of elasticity of concrete. Okay, whereas the Young's modulus of steel, you know very well, it's 2 into 10 power 5 Newton per mm square. Similarly, what will be modulus of elasticity for concrete? How you calculate this? Because for steel, you have a clear linear proportionality limit for steel, so that you can estimate modulus of elasticity by the way of stress strain diagram of steel. You can easily estimate modulus of elasticity. Whereas for concrete, the stress strain diagram not uh, is not going to give you directly the estimate of modulus of elasticity. Okay, so it's something like this. You get a curve when you draw a stress strain diagram of the concrete. Okay, so for which we have different ways of finding modulus of elasticity. So the relation is non-linear. You don't have a linear portion, unlike steel. Uh, Stress in concrete versus strain in concrete. Okay, so either initial, tangential, or secant modulus. Initial or tangential or secant modulus can be used as Young's modulus of elasticity. Okay, so maybe initial or maybe tangential or secant. Okay, so what you can see it here is the code IS 1343-2012 recommends a secant modulus at what level? At a stress level of 0.3 times FCK. Okay, roughly one third of FCK, one third of the value of FCK. Okay, so 0.3 times FCK is the level of stress at which you have to estimate secant modulus of concrete. That will be noted as Young's modulus of concrete. Okay. So why this is required? Because you don't have the linear portion in stress strain diagram of concrete. This will be introduced to you in the very first lecture of stress strain behavior, stress versus strain diagram of mild steel in strength of materials. Okay, so there the stress strain diagram for concrete is also introduced. Once again, I am reminding you to just recall what you have studied for stress strain diagram of concrete. Okay, right. So modulus is expressed in terms of characteristic compressive strength, not the design compressive strength. Okay, so like FCK, in terms of FCK, we will estimate the Young's modulus of concrete in terms of FCK only, characteristic compressive strength, not the design compressive strength. Okay, right. So let us see what does the FC, I mean, secant modulus means. Okay, so the following figure shows the secant modulus in the compressive stress strain curve for concrete. Okay. So take a cube, concrete cube, apply compressive stress, okay, and draw stress strain diagram, and that is going to be nonlinear all the way. And now you have to note stress level 0.3 FCK, okay, right? There you have to draw a line for which you have to measure the slope. That is nothing but the Young's modulus of concrete. Okay, so this is the stress level that just now we have talked about, 0.3 times of FCK. Okay, right. So this is how we estimate stress strain from stress strain diagram of concrete, the Young's modulus of concrete. The slope of this stress versus strain is curve is Young's modulus. Okay, right. And we have even got an equation that is given by the IS code that you see clause 6.2.3.1 of the IS code gives you the equation for a simple equation for estimating modulus of elasticity, Young's modulus of concrete, in terms of characteristic compressive strength FCK. Okay, so that is given by 5000 into square root of FCK is the Young's modulus of concrete. Okay, even IS 456 also gives you the same equation, whereas earlier code of previous IS 456 previous revision will give you 5700 square root FCK. Later on, that is being modified to in the latest IS codes, it is 5000 into square root of FCK. Okay, right. Now the equation given by the IS code, that you can see it here. It is in class. You don't need to remember all those equations. You can readily refer your IS code, which if you can keep it handy, You can just refer to your code anytime, so you don't need to worry about remembering all these equations what we talk about. Okay, so Young's modulus of concrete is estimated, even any other equation, even the earlier equation that I was telling, like the flexural tensile strength equation. For that matter, any of the content that you can readily refer from the IS code. So if you can keep it handy, the IS code or ready reference. Okay, so IS 1343 that you have to refer, and particularly 2012 revision 2012, not 1980. So it shall be 2012 code. Okay, year 2012 you have to refer. Okay, so actual measured values that you can even use an experiment for finding, as I said, secant modulus you have to estimate from the experimental result may differ by plus or minus 20% from the value obtained from the above expression. Okay, so that means the accuracy of this equation is given that the plus or minus 20% error may be present in this equation. That is what it means. Okay, so if you have actual measured data, you take it. If you don't have a measured data for modulus of concrete, use this equation, but this equation will have an error of plus or minus 20%. Okay, right. That is about stiffness of the concrete. So there are two things that are to be remembered here. Either you can estimate this from a test, uh, of, the cube compressive stress. You have to apply compressive stress on the cube and get a stress strain diagram. For that, you have to estimate secant modulus at the level of 0.3 times FCK stress level. That you have to get it. Otherwise, you can use a ready-made equation, which is 5,000 times square root of FCK, which will have plus or minus 20% uh, error from the actual value. Okay, so that is about stiffness of the concrete. Stiffness of the concrete is mentioned, represented in terms of Young's modulus of concrete, which will be utilized in estimating deflections of pre-stressed concrete members. Okay, right. Coming to the durability of pre-stressed concrete, uh, what are all the durability aspects that are to be looked into? Okay, so what is meant by durability of concrete? It's to ability to resist. Durable means to have a long life. Durable. Okay, so put it in terms of a definition, it's ability to resist weathering action, chemical attack, abrasion, or any other process of deterioration. Whatever the mechanism or the action that it is going to deteriorate the structure or structural element, that is to be taken as durability concern. Okay, so the common durability problems in concrete are as follows. Okay, chemical attacks, particularly sulfate attack, is very dangerous to the life of the concrete. So sulfate attack or any, for that matter, any other chemical attacks. Alkali aggregate reaction, okay, freezing and thawing damage in cold regions, Corrosion of steel bars or tendons. Corrosion is going to be a big problem. So, uh, these are the four things that are problems, that common durability problems that you can mention. Okay, so sulfate attack or any chemical attack, alkali aggregate reaction, which weakens the aggregate, freezing, thawing damage in cold regions, and majorly corrosion of steel bars or tendons. Okay. So these things are the durability concern for us. So how do you control these problems? So durability of concrete is mainly related to its water tightness or permeability. So if the concrete that you make is more permeable, it is going to be a problem for the concrete. So it will fail very early. It won't serve its intended lifetime. Okay, so you have to make the concrete water tightness. You have to improve the water tightness of the concrete. Okay, which means you have to have a packed like concrete member. Okay, so permeability should be very low. Okay, so you have to make an impermeable concrete member. So then its durability will be very good. Okay, so hence the concrete should have low permeability. So there should be adequate cover to the reinforcing bars. That is for this issue. Means corrosion of steel bars. Okay, so in general, steel bars will be kept the outer layer of the bar, either at top or bottom, or both top or bottom, top and bottom. Okay, so this is going to this portion of concrete is going to protect the steel bars to come into contact with the atmosphere. Okay, so that it won't get corroded. So adequate cover is always serves the purpose of protecting the reinforcement. Okay, and low permeability will make all these chemical attacks, alkali aggregate attacks, all these things will be controlled with low permeability. So selection of proper materials, good quality control are essential for durability of concrete. Okay, so improve the water tightness of the concrete, that will take care of the durability, and maintain sufficient cover, that is also required, and maintain good quality control. Means the way you prepare the concrete uh, shall be with the utmost quality, okay, so that it takes care of durability of the concrete. Okay, right. So durability is mentioned in IS code in section 8, where the table 4 of the IS code specifies maximum water cement ratio and the minimum cement content for different exposure conditions. Okay, so to address the durability problems, you need to maintain some minimum cement content and the maximum water cement ratio, so that your durability concern will be taken care of. Okay, So for example, if you have a very mild exposure, okay, then the cement content minimum in a concrete of per cubic meter of concrete, there should be 300 kg of cement shall be used. Okay, minimum cement content at least 300 kg. Okay, and water cement ratio should not be more than 0.55. Okay, you cannot design a concrete mix so that water cement ratio shall not be more than 0.55, and for a grade of concrete M30. Okay, this is as the exposure conditions are changing, cement content also changes, and as well as the uh, water cement ratios. So for a condition of extreme severity, extreme exposure, okay, so you have mild, moderate, severe, very severe, and extreme condition. There are 5 such exposure conditions which are given in detail in the IS code. What does mild means? What does moderate exposure means? What does severe means? What does very severe means? Extreme conditions. Okay, so all these are being given in detail into that. So refer IS code for this information, right? So what you need to prior to start with the mix design of concrete M30 mix or M40 mix. Likewise, you have to have the conditions known to you so that you don't commit a mistake in getting the right proper concrete mix design. Okay, so for the case of extreme exposure, minimum cement content that you shall use shall be 360 kgs per cubic meter of concrete. Okay, and maximum water cement ratio shall be 0.4. You can't go beyond 0.4 for extreme exposure condition. Also, the grade of concrete shall be M40. You have to use M40. Okay, so uh, the notes that you have to clearly follow. There will be some bottom line information. This usage. Okay, right, right. Next, same. Table 3 of IS code provides the values for the above quantities for concrete exposed to sulfate attack. Okay, so this is another table in IS code. Okay, as I said, you don't need to worry about remembering all these things. You have to always verify IS code for the information. Okay, so table 3 of IS code gives you for sulfate attack, which is very common chemical attack that you have to take care of uh, uh, for better durability. So the cement content, minimum cement content, and maximum water cement ratio are modified accordingly to the sulfate attack if you have. So how it is measured? Okay. So if the sulfate attack that you find is falling in these 5 categories, so it is divided into classes: class 1, class 2, class 3, class 4, class 5, where sulfur trioxide is taken as the measuring quantity for sulfate attack severity. So if sulfur trioxide is more than 2, that is taken as class 5. So for which heavy sulfur trioxide, I mean sulfate attack is very high. So hence even the type of cement that you shall use is also mentioned here. So you have to use sulfate resisting cement, or super sulfated cement also is available with the protective coatings. So minimum cement content 400 kg per cubic meter. This is for the type of exposures that we have studied in the last table. Okay, and what cement ratio 0.4. Right. So this is uh, what happens when to assure the durability of the concrete when you have sulfate attack, that this table must be referred to. Okay, so table 3 of the IS code gives you the minimum cement content and what maximum water cement ratio, type of cement to be used for the case of sulfate attack. And table 4 of IS code will give you for different exposures what shall be the grade of concrete, cement content, minimum cement content shall present in the concrete, also maximum water cement ratio limitation. Okay, so these are all to take care of the durability concerns of the concrete, and ultimately the maximum cement content to limit the creep and shrinkage losses that we will be studying further sessions. To limit the creep and shrinkage, the IS 1343 specifies a maximum cement content of 450 kg per cubic meter of concrete. So, at any cost, the cement content shall not go beyond 450 kg per cubic. Okay. So earlier code of IS code, it was 530. Even IS 456 also suggests IS 456 suggests 530 kg per cubic meter of concrete. So latest revision of the IS code gives you 450 kg per cubic meter of concrete. Okay. So this is about the durability aspect of the concrete. Okay. So stiffness is to take care of the stiffness property of concrete. We have studied the stiffness property in terms of Secant modulus, and now the durability. What factors will affect the durability of concrete? How to control them, and related table 4 and table 3, which are essential for addressing durability, to choose cement content, water cement ratio, and the grade of concrete, type of cement also, case of sulfate attack. Okay, right. So at any cost, the cement content shall not go beyond 450 kg per cubic meter of concrete. Okay. Next session, we will talk about the high performance concrete, which is different from high strength concrete. Okay, thank you.